Hi there, it's Dr. Embuddy, and we're going to take a look at Project 7. The basic idea behind Project 7 is we have a social network, and how do you recommend friends? We actually got some real Facebook data, but what I'm going to work with today is this small file that we have, and the function test cases work off of that, and that gives us an idea of how exactly this works. Now, we're going to do the simplistic notion of, among friends, who do you have, or among people, who do you have the most friends in common with? And those will be the ones recommended. So that's what we're trying to do. I've got a social network, and how do I make recommendations for new friends? Well, I'll look at everybody, see who's got the most friends in common, and then we'll use that. So first of all, we have to build the network. Then we have to go and get a count of friends in common. And then we go and look at that information and see who have the most friends in common and make a recommendation based on that. So there's multiple steps there, and we have functions that deal with those. And so what I want to do today is walk through the concept of each of those functions, and there's tests for each one. And you can pretty much in this project build those functions one at a time, and then you can think about, okay, so now I've got these tools, these particular functions. How do I go and solve the problem at hand? And so again, like we've done many times before, we're using decomposition. We're breaking this down into smaller pieces that are relatively easy to handle. So with that, let's take a look. We're going to start with this small network data file that we provide. And I show it here on the right. The first line is how many people are in this network. So we've got 10. And then there are the connections. So the first line says 0 and 1 are friends. Second line says 0 and 2 are friends. 0 and 3 are friends. 1 and 4 are friends. All the way down until we see that 7 and 8 are friends. So what I want to do is build a list of lists that has a list for each person. So for example, let's take a look at 0. Okay. 0 has friends 1, 2, and 3. And so that is going to be a list of the friends of 0. How about person 1? Well, person 1 has 4, 6, 7, and 9. I can read that right there. How about person 2? Well, we already know that 0 is a friend, and then we now pick up 2, 3, 8, and 9. And so on, and we go and build this. Now what we make as a suggestion, as an algorithm, is the following. Start out with a list of lists that are all empty. And so on. And this is, so I'm showing this as a bunch of lists, but we make one gigantic list around all of that. So I have a list of lists. And I will go through here, and we see that 0 and 1 are friends. And my suggestion is that, okay, I will say that 1 is a friend of 0, and so that means 1 that means 0 is also a friend of 1. And so I'll want to put both of those in there as soon as I read that line. Then when I read the next line, which has a 0 and a 2 in it, then I see 0 has a friend 2, but that also means that 2 has a friend 0. And I keep going through. When I read the line 0, 3, that means that 0 has a friend 3, but that also means that 3 has a friend 0. And we keep going through that. I get 1 and 4, so 1 has a friend 4, and so that means that 4 has a friend 1. And so on. And we go and build this. So every time you read a line, you make 2 entries in here. So when I get to 1 and 6, there's 5, there's 6. So 1 and 6 says that 1 has a friend who's 6, and 6 has a friend who's 1. So every one of these means that I fill in 2 entries here, and we build this up. And the way I address these is that if my list was called L, and I want it, and what I'm going to do here is every time I come across one of these, I'm going to start with empty lists, then I will do an append. So when I said, let's just go to the next one. 1 has a friend 7. So I will take my major list here, and person 1, that list dot append a 7 to it. And then I will take oops, that's not writing very well. Let me move over here. Then I will take person 7, their list, and append on a 1 onto it. So I do 2 of them. List 1s, I append a 7. List 7, I append a 1. And that's how I build up this matrix. And that's what happens here. So the end result is function test1, testing the read file function. We read my small network data file. Here is the network. Notice that there is a big list. This is a list of lists. And inside of that are all these little lists. There's a list, comma. There's another list, comma. And what I did is I took these lists, so this is list 0, that's list 1, that's list 2, and list 3, and I just printed them out a little nicer. Here's list 0 is 1, 2, 3. There's the 1, 2, 3. List 1, 0, 4, 6, 7, 9. 0, 4, 6, 7, 9, and so on. So this and this are the exact same things. I just printed this out so it's a little easier to read. Here is the actual list. And I called it network. That's really my social network, right? So person 0 has friends 1, 2, and 3. Person 1 has friends 0, 4, 6, 7, 9. And we build it just the way I described it. And that's the read file function. We read a file, I create this, and that is test 1 that does that. All right, now I have my social network. Right, I've created, I have this file of information, and I have created a social network. What do I do with it? Well, as a start, as a helper function, we have this thing that says the number of common between 2 lists. Actually, let me scroll this down a little bit here. Yeah, this is better. All right. So what I'm going to do is I'm going to take 2 lists, and I'm going to take network 1, that's this guy, and I'm going to take network 2, that's this guy, and I'm going to take those 2 lists, and notice network is a list of lists. So network 1 is 0, 1, that's this particular list. And network 2 is that particular list. So inside of my function, I just simply have a list. So I start with a list of lists, I peel off one list, I peel off another list, and I send it into my function. So my function is looking at this list and this list. And now we're asking the question, how many do they have in common? Well, I just go through and they both have a 0, they both have a 6, they both have a 9. They happen to be in the same places here. That's pure coincidence. So how many do they have in common? 3. All right. And like I say, just to help you out, the output, the result should be 3, and it is. Okay. And then the other one that we work with is these two in that test. So when I look at those two lists, what's in common? They have a 4, so the result is they have a 1. So you need to walk through these two lists and count how many they have in common. I'll leave that to you. So I use that helper function in the next test, which is the function calc to calculate the similarity scores. And what we're doing here is we're building what's known as a similarity matrix. This is another list of lists. These are the counts of all the friends. So here is, again, this is a list of lists. So we've got a big list here, and inside we've got a bunch of little lists. So that's list 0. Now this time they're all the same size. All right. And then this is 1. And so on. I've got all these little lists, which, as before, I wrote them out nicely, just because it's a little easier to read. So what I'm doing is I'm going through, it's using network, that is, it's using this, and we're going through this to try and see who we have, how many friends we have in common. So when I look at 1 and 2, so person 1 and 0, 1, 2, there's the 3. That's this 3 right there. That's how I found that guy. And when I look at person 2, and their count with respect to person 1 is the same. So this count appeared in 2 places when I looked at 1 and 2, and similarly with 7 and 8. Those two guys, right? So that's the ones from here. So what you do is you use this set of lists, and you keep passing them to this function, and you use that to build this list of lists. What I do is I give you so this one is a 10 by 10. I give you a function that initializes all these with zeros. All right, I give you that function. And now what you do is you go through network, call how many in common, so you pick 2 people, who do they have in common, and then you fill in the corresponding places in here. So again, it's still working off the same set of data here to build that similarity matrix. We're building these one at a time. The final piece is, how do I make a recommendation? So I need to make a recommendation for 3. So that's, again, as before, we have a list of lists. Right? And then I wrote it out nicely here. So we look at person 3, and we say, who should I recommend as a friend? And that will be the one with the most. So you look through this, and the first thing you might think of is 4. Well, that's person 0, 1, 2, 3. Oh, hey, that's myself. Well, I'm not going to recommend myself. All right. So we don't consider that one. Then we look and we say, oh, well, the next biggest number is in position 0, 1, 2. Well, okay. One thing I need to do at that point is scroll back here and say look at person 3. Oh, wait, we're already friends with 2. So we don't want to use that. So we're already friends with person 2, so we don't want to use that. Now, this time I've got a tie. All right, there's person 1 and 0, 1, 2, 3, 4, 5, person 6. Doesn't matter which I choose. All right, I chose person 1, but in fact either one is either one is a correct answer. But notice how we went through that process. So once I've got this matrix, it's pretty simple. Look for the biggest number. Oh yeah, but we don't want to take myself, and we don't want to take any of the ones that are friends, so I have to check back with my network, and then I can return who I'm recommending as a friend, and we do it twice in here. So once you've got these pieces, now I have this recommend function, and you can just prompt for a person and then make a recommendation. And of course, as we saw here, there may be more than one recommendation, and either one is correct. Doesn't matter. And we're only reporting one. You know, we could make this more complex and say, oh, we'll recommend everybody who has the same values, but we're not doing that. And once you get it tested with these, then we give you, so we run a couple of samples with the small network. Again, with the small network, and then we go and we say, let's look at some real data out of Facebook. And as before, when we're dealing with data, this is a big file, so we grab a few. So this has 0 to 999. It's got 1,000 people in there. And so we just select some things to make some recommendations. Notice one of the things that you have to do is you have to look at the file and see how many are in there, so that these numbers are different. Notice in the small file we only had 10 people, so you have to do that. And so each one of these, so I got friend 20. And who do you recommend? Well, person 116, and so on. So hopefully this will give you, notice I've talked about design here, all about the algorithm. How do each of these algorithms work? Now you're still going to have to do the Python for that, but we've broken the problem down into smaller pieces that hopefully you'll be able to handle. Good luck.